guys, Code with Lawrence. Today we are going to write a C program to calculate the root of a quadratic equation in the form ax squared plus bx plus c. Without waste of time, let's get started. First, to add the library, standard input and output library, to obtain input from the users. Second, another library, maths, for mathematical calculations. So now, the main program. The first thing we have to do now is to declare our variables. So we are going to declare double data type for our variables a, b, c. As you can see here, this is a, b and c. They are inside this equation. We need to also declare double as a discriminant. In the root of the equation, you have x here, so and we're going to have two roots, x1 and x2. Again, we will also declare a real part, should in case the roots are complex, and the imaginary part. Okay, that's it. I'm done. We need to ask the user to enter the coefficients of a, b and c. So ask the user to enter coefficient a, b and c. So enter the coef of a. Great. After asking the user to enter the coefficient of a, b and c, we have to check if it's a quadratic equation. Check if it's a equation. If a is equals to 0, a is equals to 0, what do we do? Print f. This is not a quadratic equation. Why is it not a quadratic equation? Because a cannot be 0. Then we return 0, which means I'll end the program here. Now, what will happen? We now calculate the discriminant. Let's calculate discriminant. So discriminant equals to b times b. You have 4 times a times c. Then now let us check the nature of the roots. Check the nature of the roots. How do we check the nature of the roots? If the discriminant is greater than 0, it means that we are going to have 2 real and distinct roots. So we have 2 real and distinct roots. So we have to calculate the roots. X1 will be equal to minus b plus the square root of the discriminant divided by 2 times a. X2 equals to minus b minus the square root discriminant divided by 2 times a. Then we print output. So we're going to say that roots are real and they are distinct. So print out the roots to the user. S1 other roots. Else if discriminant is equals to 0, means I'll have 1 real roots. So let us calculate that root. Then we print the root to the user. Roots are real and equal. will simply be minus b divided by 2 times a, then the imaginary part equals the square root of minus discriminant divided by 2 times a. Then we output and let the user roots are complex and imaginary. X1 equals plus I real part imaginary part. For the second root, x2 equals to percentage 2 f plus percentage f I real part imaginary part. Wow, I've come to the end. Now return 0. Don't forget to save. Then I run. If I run, let me show the code again. Those are the codes. So click here to run the code. I'm using Visual Studio Code, that's why I'm running it this way. I'm running at the command prompt of quadratic equation that's what it is running. Enter the coefficient of a, let me enter 1, b, let me enter 1 again, c, let me just enter 1. See, roots are complex and imaginary. Let me run again. Input now. Input 2, 5 minus 3. Roots are real and distinct. That's good. Now let me run again and enter 0. See, this is not a quadratic equation. It cannot be 0. So guys, that is it. Thank you. If you like it, subscribe and share.